So, I'm just going to quickly show you the compressor, and this one, it's really noisy, so apologise if it does. We've got it set to 1.3 bar. I'll try and close the door as best I can. Keep some of the noise out. So, just to give it a bit of a demonstration. Okay. So, it's caged, and let's start the clock. So what should actually be happening during this experiment is that this should be moving clockwise as viewed from above at a rate of 3 degrees every 15 minutes at my location, and this should also be leaning over like this. Obviously I've exaggerated it there, but that is what should be happening. Just a quick demo of it working. I've just spun it up and took the case off. And cage it again. If I apply a small amount of pressure onto this bottom gimbal, you can see it preset in there. So this cage knob resets it back parallel to the instrument itself. So it's important that we cage it before we do the test. So during straight and level flight, this whole setup here is not experiencing any friction on any of the bearings, only perhaps on the spin axis bearings of the spinning rotor itself, but that doesn't induce any mechanical drift. It's only the gimbal bearings that induce the mechanical drift. So in straight and level flight, nothing is moving, so no friction is being generated. If the pilot makes a maneuver that induces some sort of movement onto any of either this axis or this axis, it will result in a cumulative build-up of drift caused by all the friction. And this is exactly what the 3 degrees of drift every 15 minutes is for on every single gyroscope, no matter where it is on the Earth. So by not allowing it to move, i.e. testing it as we are doing on this flat level surface, we are not allowing any mechanical friction to induce onto any of these bearings. So if we eliminate mechanical friction or mechanical drift, all that should be left is apparent drift, which of course is what we're testing for right now.
So it seems to me like this would be the easiest experiment to perform in the classroom, to demonstrate the spin of the Earth to children. The experiment's very simple. You set the gyroscope spinning at the beginning of the class, and these gyroscopes could be easily mass produced in this day and age using electric motors. And you would give the student a map and get them to locate their current position on the map, find their latitude, then give them the sine formula to calculate the drift angle, get them to plot it on a graph over time, and this will obviously produce a sine wave. What better way to combine geometry, geography, maths, science, orbital mechanics, and obviously they will be able to check their result and check their calculations by reading off the angle on the gyroscope. But of course, nothing like this is ever done, and I think I'm beginning to see why. Unless of course I've got the only directional gyroscope in existence that doesn't register apparent drift. I mean, maybe I should donate it to a gyroscope manufacturer and get them to study it and see if they can replicate it as to why it's not showing apparent drift. If it's such a problem, then just study this one and replicate it. Problem solved. Anyways, I put a challenge out there a while ago for anybody to come up with a video demonstrating with any correlation at all to their position on this Earth any apparent drift whatsoever. And as far as I know, nobody has come up with anything. We've had lots of people coming up with no movement on their gyroscopes, but nobody demonstrating anything that resembles movement in any shape or form. So the challenge still remains, and I'm not talking about ring laser gyros or anything of that ilk. I'm specifically talking about the types of gyroscopes that Leon Foucault and the US Navy claim show apparent drift. Anyways, I'm going to sign off now and leave you to watch the rest of the video. It goes on for 15 minutes, this experiment, but spoiler alert, it doesn't move. I hope you've enjoyed watching the video as much as I've enjoyed making it. I'll be back with another video hopefully soon. Cheers folks.
Okay, that's 15 minutes up. Let's just show that it's still working as it should. $270. Back to 0. So 0 apparent drift at all.